Okay, so adding and subtracting, we're going to start with your normal fractions, remembering that to add any fraction, you have to have a common denominator. This one already does. So you keep the denominator the same and add the numerators. Reduce it if you can. Okay, obviously that you can. In high school, we don't very often show as a mixed number. So I know in elementary, junior high, you may have always converted that to, that would be 2 1/3. But really in high school, we keep it as an improper fraction, keep it in lowest terms. And that's really because we can then use it in another set of questions. Yeah?
When the answer comes as a mixed fraction, you just fraction again?
Well, if you're going to do an operation on it. If it comes and there's nothing to do, or you're just asked to, I mean, sometimes you can add with it and it's okay, but often you have to convert to a proper fraction. Most times we don't give them to you like that. So here you need a common denominator. So I look, biggest number is 4. Okay, the other fraction denominator go into it. It does. So that's my common denominator. So I write out my two denominators. This one doesn't change. This I have to multiply top and bottom by 2. Okay? So that's going to be 22. Then keep the denominator the same and subtract the numerators. Okay? With subtracting, if I were, because a common mistake is people will add the denominators as well, or subtract them. Obviously, if I subtracted here, I'd get a negative, which you can't have negative fractions, but this doesn't make sense. Here, if I subtracted, I'd get 0. And that doesn't make sense. So always remember, adding and subtracting, you keep that denominator the same. It really gets important to remember that with rational expressions, because sometimes students forget. This one, I look at the bigger one, 11 doesn't go into it. No common factor. 11 is a prime number, so my lowest common denominator is 132. 11 times 12. Okay. So here 132, 132, and so here I have to multiply by 12. Here I multiply by 11. Now I don't know what 12 times 16 is. Okay, 190 something. Just give me a sec. I should get my calculator out anyway. 192. Okay, just give me a sec. 92, someone told me, right? So 12 times 16, 192. Keep the denominator the same. You can just subtract 55 right away. Oops. Another 50, you can register it, so 137. Okay, and you're done. Nothing is in common. You can tell me what the divisibility rule is for 3s. How can you tell if any number is divisible by 3? Thomas?
If you add up all the digits and add up to a multiple of 3, then it's divisible.
Exactly. Same with 9, right? Add out all the digits. If those are divisible by 9, then the whole thing is. So that's how you can quickly tell, like this is divisible by 3, obviously by 2 as well. So if it's divisible by 3 and 2, you know 6 goes into it, right? This one is not divisible by 3 because if I add those up, that gives me 11, right? So you know you can't divide those in. Okay, so. Oh, one more. So this one here, 10 doesn't go into 15. So you could say a common denominator is 150, 10 times 15. That's not your lowest common denominator though, right? So if you do use 150, you'll have to reduce at the end. Here, this is 2 times 5, this is 3 times 5. So really your lowest common denominator is going to be 2 times 3 times 5. Which is 30. Okay, so here, 30. So multiply this by 3, this by 2. So 21 plus 8 is 29 over 3. None of those, we couldn't reduce any of those once we added them together or subtracted them. Sometimes we will, okay, but those ones we couldn't. All right, so taking a look, we're going to first look with monomial denominators. So that means just a number, or maybe a number and some variables multiplied together. But our first group of questions, there's no binomials in the denominator or trinomials. Okay, so we're going to simplify that. Reminder, create a common denominator by multiplying numerator and denominator by the same expression. Determine non-permissible values and subtract the numerators, keep the denominator the same. Simplify, and again, I like divide out. Okay, so the reason why here it says by the same expression rather than the same number is you might have to multiply by something with a variable in it, okay, which is an expression as opposed to a number. This one here, really straightforward. Already have the same denominators, so we're asked to add. So really our final answer, denominator of 4, 3m plus 11m is 14m. 1 minus 6 is negative 5, so that's 14m minus 5. Super straightforward. You're not going to have many like that. Okay. Are there any restrictions? No, because there's no variables in the denominator, right? So you're done. That's it. On the next one. Okay, next is denominators of 2 and 4. Look at the biggest one. Does 2 go into 4? It sure does. So now this is going to have a denominator of 4. This already has a denominator of 4. So here I have to multiply top and bottom by 2. Just remember that you have to multiply by everything by 2 in the numerator. So it's like having brackets there. So if you want to show that step, you can with the brackets, or I'm going to show it there and expand out. So that would be 6x plus 2. Okay. Now, be really careful. Some of you on the last test struggled with subtracting expressions because you forgot to change the sign. Really important on test on Tuesday as well. I'm going to show it as one fraction now. Okay, because why not? And 6x plus 2, but I'm going to show this subtraction. I'm going to take a step for it. I'm not showing my final answer. That's like having brackets around that. So when I subtract everything in the numerator, it's going to be subtract x plus 5. Okay, subtracting everything in that bracket. So be really careful on that. Then collect like terms. You get 5x plus 7. Okay. Now with any algebraic expression, remember I think we talked about this back in the expanding part, you can check obviously by redoing your work. Okay, another way of checking, because this isn't really like factoring and simplifying, where they're totally opposite. We're just combining them. So what you could do is substitute a value in for x. Don't choose 0. Choose any non-zero number. Let's say maybe a 1. And if you put a value in for x everywhere in the original, find the value. Put it in your answer, find the value, and it should be the same. Okay, so I usually choose x equals 1. So that would be a way of testing. For example, here, if I do this in my head, that would be 3 times 1 is 3 plus 1 is 4 over 2 is 2. I'm just going down here. Minus 1 minus 5 is negative 4 over 4, which is negative 1. So that gives me 3. If I put 1 in here, I get 5 plus 7 is 12. 12 divided by 4 is 3. Got the same thing. If you had forgotten about this and put subtract 5, then you would have had minus 3 here. And so then you would have 5 minus 3, which is 2 over 4, which is a half. Not that. Okay? So that's another way of testing. All right. So those had numbers in the denominator. Again, no restrictions. Now we have some variables in our denominator. Okay, take a look. Sometimes we'll want to see if we can divide out anything within a fraction. So factor, but can I factor 5n squared minus 4? Thumbs up or thumbs down? Down, because of the 5, right? So, although n squared is a perfect square and 4 is as well, 5 is not. So, all we can do is find our common denominator. And what you might want to get into the practice, I'll do 2 terms for right now. But you might go to just one like this. In any case, 2n has the common factor of 2n in the second fraction. So all we need to do is multiply by 4, top and bottom. Okay, so this will be 8n here. So if I expand that out, that's going to be 20n squared minus 20. Oh, minus 16. Sorry. Yes. Remember, it's Friday. So Fridays, I do tend to make more mistakes. Minus 16. Okay, so then 8n. We're just adding, so we don't have to show anything different. Collect like terms, that's 20n squared minus 3. Okay? Nothing that you can divide out. There's no common factor here. If there was, say, some even number, you could factor out a 2 and then divide something, but not in this one. And then our restriction, m can't be 0. Next one. So, nothing to divide out. We've got, I always look at kind of the bigger one, bigger degree. So, just within the numbers 8 and 12, we could multiply them together, but that wouldn't be the lowest. Your lowest common denominator would be, thinking about that, we have 4 in common, and we need a 3, what's in common, this is 4 times 3, this is 4 times 2, so I need 4 times 3 times 2, which is 24, and then I need a squared. Highest degree, so highest exponent on the variable. So this will be 24a squared, this will be 24a squared. Okay, so this one I have to multiply by 3a, and this by 2. Okay. So that's going to be 9a, and that's going to be minus 10. You could have actually, for this one, just gone straight to this. Okay. You know, like terms, right? And a can't be 0. There's no adding or subtracting in the denominator, so there's not going to be, the only restriction is going to be 0. Okay, we're going to keep going a little bit. Okay, so the next one has 3 terms. Okay, so 3 denominators to look at. So your lowest common denominator, so we have to have 2y, we have to have x squared, and we have to have 4x. So that means we already have a 2 from there, so by another 2, and we've already got an x. So really 4x squared y is your lowest common denominator. So take a look at the factors of each denominator and make sure they're included in your lowest common denominator. Make sure they divide into it. Okay, now I've been showing separate fractions. If you want to do it all in one, then you can. This would be 4x squared y. And then you're just going to use brackets and show your multiplication. So for example, here, I'm going to show, so in order to get that denominator, I need to multiply this by 2x squared, top and bottom, right? It's getting a little squishy in there, so maybe you want to just show it all on your next step, okay? If you show it all as one here, then you're not really creating too many more steps. The next here, I need to multiply by 4y. And then here I'm subtracting, and what do I multiply this by? xy times 2y plus 1. Let me see if I can move this. Okay. So now you expand to get rid of the brackets. And if this didn't have an adding in it, I mean, it would be fairly straightforward. Okay, but we have two terms there, so when we subtract, the sign's going to change. So be aware of that. You want to show your work for that. So xy, negative xy times 2y, negative xy times 1. Now, really, we should try to put it in descending order of degree in that numerator. So 6x cubed, degree 3, then another degree 3, and then an x and a y term, and a 28y squared. You should check for any common factors, so that will divide out with this. Okay, if there's a common factor of 3, it doesn't really matter because you can't simplify it. But look for, are they all even? Close, but this doesn't have, this is 1. So there's nothing to do there. Is there x in all of them? Close, this doesn't have it. So that's as far as you can go. Okay, and then x can't be 0. Oh, did I forget the y? Oh, poop. See, it's Friday. Darn. Okay. Sorry. Y there I missed. And y here. So I should check. Does every term have y in it? No, this doesn't. So it's still in most terms, but yeah, get that y in there. Okay. We're just going to look at the next part. I think I'm just going to give you some more time, but let's just see. Let's just do the first one, just so you can kind of see what it's like when you have a binomial denominator. Okay. So really, the only thing is this part, fully factor. So within each rational expression, simplify it like we did 2 days ago, then find your common denominator, okay? So the thing to note here, remember this x in this denominator is not a factor. It has a plus next to it. So your common denominator is not x plus 4. This is different from this. It does not have a factor of x. If it did, then you could divide those x's out, and we know that we can't. So your lowest common denominator is kind of like when you have 1/3 plus 1/5. You multiply them together. So our lowest common denominator is x times x plus 4. We don't expand out. Leave it in factored form like that. And so this is where I do tend to show it as one fraction so that I don't have to keep writing out that denominator because it gets tedious. You're going to multiply here by x plus 4. So really, that's 5 times x plus 4 in brackets. I'm going to show that step. So I don't really have to show it there. I'm going to show it here. And then plus, here we have to multiply by x, top and bottom. So that'll be x times 6x. Or 6x times x. Doesn't really matter. And then I expand to get rid of the brackets. But I keep my denominator in factored form. Okay. Then take a look. It's a trinomial. Rearrange it to be descending order of degree. And then see if you can factor that. I don't know. Are there two numbers that multiply to 120 and add to 5? So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20. 7, 8, and 1, 8 and 15, getting close, 10 and 12. So, there aren't any, so you just leave it like this, okay? The restrictions, 0 and -4. Okay. So that's where we'll leave it for today. We'll finish the rest on Wednesday, actually. Okay, so you have the rest of the period. You can work on the beginning part of the adding